everyone. In this video we will solve more problems on calculation of percentage labeling of oleum. So it is given that an oleum sample is labeled as 118%. So this is oleum sample which is labeled as 118%. So as I told you that it is 100 gram of oleum sample, and in this sample 100 gram of water is present. As we have studied in the first lecture of oleum that 100 gram of oleum will be present. We can say that 18 gram of H2O is present in 100 gram of this oleum sample. So we can calculate the mass of free SO3 by writing this equation SO3 plus H2O. This will give H2SO4. So obviously for 1 mole free SO3 reacts with 1 mole of H2O. We can say that 18 gram of H2O. We can say that 80 gram of free SO3. So for 18 gram of H2O from the labeled sample, definitely 80 gram of free SO3 will be present. So definitely the mass of free SO3 in the first case for 100 gram of oleum sample will be 18 gram. This is writing. We are writing for this for 100 gram of oleum sample as it is asked in the question 1. Now the free SO3 is 80 gram and the oleum sample is 100 gram. So we can calculate mass of H2SO4 as 100 minus 80, that will be 20 gram. So the 20 gram H2SO4 will be present in 100 gram of oleum sample which is labeled as 118%. Now how we can calculate the combined SO3? So combined SO3 present in this. So we can write the equation for this as 98 gram of H2SO4. Since 98 gram of H2SO4, then 80 gram of combined SO3. So we can calculate for 20 gram of H2SO4. For 20 gram of H2SO4, it will be 80 by 98 into 20. This will give 16.32 gram of combined SO3. Now the same data is to be calculated for 200 gram of oleum sample. So how we can calculate this? For the 200 gram of oleum sample, how we can calculate the free SO3? So because in 100 gram of oleum sample, 80 gram of free SO3 present. We have calculated this in 100 gram, 80 gram of free SO3. So for 200 gram of oleum, the amount of free SO3 will be 160 gram. It will be 160 gram. So mass of H2SO4 will be 200 minus 160, which will be 40 gram. In the same way, we can calculate the mass of combined SO3 as 98 gram of H2SO4 and 80 gram of combined SO3. Now at this place 20 gram, we can put the value of mass of H2SO4 as 40 gram and we can calculate the amount of combined SO3, that will be equal to 80 by 98 into 40. This will give 32.65 gram. So this is the way to calculate the free SO3, amount of H2SO4 and the combined SO3. Now we are taking the second question in which it is given that the number of moles of KOH required for complete neutralization of H2SO4 produced from dissolution of 500 gram of 118% oleum in water is nearly. So this is 500 gram of oleum sample is given. It is labeled as 118%. So first we will find the amount of free SO3 in 500 gram of oleum sample. Because the 18 gram of oleum sample, 118% of oleum sample means 18 gram of water is required for 100 gram of oleum. So obviously we can say that in 500 gram we want to calculate free SO3. 4. Since 100 gram of oleum, 80 gram of SO3 is free SO3. So we can calculate for 500 gram of oleum sample. It will be 400 gram. So the mass of free SO3 present in the 500 gram of oleum will be 400 gram. Now we can calculate the moles of H2SO4 by using this equation. SO3 plus H2O will give H2SO4. So SO3 is 1 mole, H2O is 1 mole. So we can say that it is 80 gram, it is 18 gram, right? And it will be 98 gram. So since for 80 gram of free SO3 we are calculating 98 gram of H2SO4. So we can calculate amount of H2SO4 for 400 gram of free SO3. It will be equal to 98 divided by 80 into 400. This will give 590 gram of H2SO4. 590 gram of H2SO4 means 590 divided by 98. This will give 6.01 moles approximately. Now to neutralize the complete H2SO4 produced, this is 6 mole of H2SO4 is produced. So the amount required to neutralize this will be twice of definitely KOH, as we discussed by this equation, that H2SO4 plus 2 KOH will give K2SO4 plus 2 H2O. So the amount of KOH will be required will be twice of H2SO4. So it will be twice of 6.01. So approximately 12 moles of KOH will be required for the complete neutralization of H2SO4. Let's take another example. If a sample of oleum mole fraction of SO3 0.5 is given, now we want to label the oleum sample. So labeling of oleum sample is given as 100 plus X. And recall what was X. X is minimum mass of water required for 100 gram of oleum when no free SO3 left. We have discussed this in the last concept, in the last lecture. So we will calculate the minimum mass of water which is required for 100 gram of oleum sample so that no free SO3 is left. Because the mole fraction of SO3 is given as 0.5 and we know that oleum is simply homogeneous mixture of SO3 and H2SO4. So obviously somewhere equal moles of these are present, suppose 1 mole of each. That's why the mole fraction is 0.1. So we can say that mole fraction of SO3 will be equal to mole fraction of H2SO4, that will be equal to 0.5. So total mass of Oleum sample will be equal to 0.5, which is the moles of water, into 80, which will be the molar mass of SO3, plus 0.5 into 98, which will be the molar mass of 98 H2SO4. So this will give the total mass of Oleum sample will be 89 gram. So to label the Oleum sample, we want to calculate the mass of water which is required for 100 gram of Oleum sample. So obviously for 89 gram of H2SO4, 89 gram of Oleum, 9 gram of water required, because 40 gram of SO3 required, because 0.5 moles of SO3 is considered. Mole fraction of SO3 is 0.5. So with respect to SO3, the moles of SO3 and the moles of H2O will be equal by this reaction. So 9 gram of H2O is required for 89 gram of Oleum. So to calculate the X, we will calculate this amount of water for 100 gram of Oleum. This will be 9 upon 89 into 100. This will equal to 10.11. So definitely this will be equal to 100 plus 10.11, that will be equal to 110.12%. So this will be the labeling of Oleum sample. Let's take one more example, that calculate composition of final solution if 100 gram of Oleum labeled as 109%, which is added with 9 gram of water. So let's take A part of this, and we know that H2SO4 plus SO3, the Oleum sample, which is definitely 109% label, which clearly means that 100 gram of Oleum contains 9 gram of water. And in this case we are adding the 9 gram of water, which means that 9 gram of water is required and 9 gram of water we are adding. So definitely maximum 109 gram of H2SO4 will be formed, and there will be no free SO3 present. Have a look on this, that we are adding the water as much as required by this Oleum sample, so that no free SO3 will be left. In the B part we are adding more water as much required, because 9 gram of water is required and we are adding 18 gram of water. So in the case 2, 100 gram of Oleum, right, and in this we are adding 18 gram of water. So definitely 109 gram of H2SO4 maximum, that will produce when no free SO3 will be left. and extra 9 gram of water will be formed. Extra 9 gram water will be formed. So in the final solution, H2SO4 and H2O will be present, and to be noted that this sample is not oleum. This is not oleum. We can take the C part of this. We know that the required amount of water is 9 gram and we are adding 120 gram of water. So now this 100 gram of oleum, and now we are adding 120 gram of water. Obviously excess of water we are adding, so definitely as per the labeling, maximum 109 gram of H2SO4 will be formed and remaining 111 gram of H2. Obviously again the final solution contains H2SO4 plus H2O, which is 109 gram, which is maximum amount, and water will be 111 gram, because out of 120 gram of water, 9 gram water is used to convert the entire free SO3 into H2SO4. So these are the problems on the concepts of percentage labeling of oleum. In the next videos, we will discuss about the iodometry gas analysis. Thank you very much.